Good morning, all. Let's begin lecture 7, in project duration. Not sure if you can remember contents of lecture 6. So today we will continue from lecture 6 to how we can reduce the total project duration. From the lecture heading, you can see that it's all about the timing of the project. That means how we can reduce the overall duration of the project. But from lecture 6 and all the previous lectures, we got an idea that the project duration cannot be changed from the critical path. The critical path gives us the minimum duration that a project must need to complete. So today we'll see how we can crash that. I mean, how we can reduce the duration even from the critical path. So last week's lecture was scheduling resources. Now today we will see, I hope you can hear me all. Okay, I will come back to questions in the middle of the lecture when I'm giving a break. When the case studies will be marked to be published as soon as possible. Okay. Okay. Can you hear me? All? Okay, that's great. Okay, now let's move on. So last week we had we discussed on resource schedule. How we can flatten the resource demand over the specific duration of the project. Now today we'll see how we can reduce the project duration. So the question is, if we have a critical path which defines the minimum duration of the project, can we really reduce the duration even further from the critical path? We can do it, but obviously there are some specific procedures. There should be some trade-offs. That means we need to spend some more money, we need to allocate more resources to reduce the duration of the project. Again, that relates back to resources and cost. So depending on situation, we can trade off between resources and cost. Need be, the overall project duration can be reduced. Okay, now, why we need to reduce the project duration? There are many reasons that we're investing into something or investing money into something. We will make sure that the return on investment is good enough. That means the money is well invested, and the total time duration of the project, if it is that into that critical stage that we really need to look into the total project duration, there is no other option. So we need a time cost trade-off. And reducing the project duration, there's only one way. We have the duration of each activity within the critical chain and other chain of project network diagram. We can reduce the duration of each activity. The term we use here is known as crashing. So crashing an activity, that means invest some more money, more resources into a specific activity, and then crash it, reduce it by a day or two. And over the period of the project, we can possibly come up with total project, considerable reduction in the overall project duration. Why do we do it? Why we need to look into reducing the project duration? Things like if there is a time to market threshold, number one point. That means if we are competing with any external competitors, if there is a time delay in in any specific product to come to the market, time is a real critical factor. So time to market, we need to reduce the overall project duration. Unforeseen delays, incentive contract. This is incentive contract. Those who are doing the contracts and procurement, you should have a clear understanding of what is incentive contract. But in brief, if you can finish a project early, as part of the standard contract, there will be some incentives given to the project team. So if it is an incentive contract, there will always be a push that to reduce the overall project duration. I'm not sure who is this coming by default? Is anyone trying to write on the screen the blue lines? Where is this blue line coming from? Okay. Okay. Then these are some basic checklists. If there is an imposed deadline, any contract commitments that we must finish, if we are competing with other project coordinators, that we must finish the project within at least 3 days earlier than the scheduled time, or if there is a goodwill and public goodwill cost. These are the factors that are, that we usually consider whether the extra money that we are investing will pay us back. Now, there are obviously two options. If are not constrained, we are not really constrained by the resources we have. That means we can add additional resources or adding more resources to finish it early. Outsourcing project work, if money is not an issue, we can possibly outsource some part of the project work to some external parties. Scheduling over time, again, paying extra money to the workers to work overtime and reduce the overall project duration. Then establishing a core project team that will be purely focusing on the core project activities. Do it twice. So this is interesting. Do it twice. This is something like it can have two advantages. First of all, it can have an early time to market, which is say for example, if it's a software or a mobile phone or something like an upgraded version of the software, an online platform. If time to market is important, you can consider to release a rough version to start capturing the market share, and then revise it in a few months' time, release the upgraded version. So this is a very common practice mostly in the software industries. You can see that many software has been released early, and then you can always upgrade. The latest versions are coming quite often. So do it twice. That means very fast, do a very rough job, release it, and then try to modify it and refine it over the period of time. If the resources are constrained, now this becomes really, really critical. If the resources are constrained, how do we actually minimize the overall project duration? That becomes a bit tricky. If can you really do it? It all depends on the project managers that are handling the overall project. Some of the ways could be improving project team efficiency, but again, this is not a single day task. It builds up. Team efficiency usually built up over the period of time. Fast tracking, critical chain project management, we call it CCPM. That means purely focusing on the critical chain, and every activity within the critical chain I mean, revisit, reanalyze whether anything can be done to reduce the total project duration, reducing project scope. So that means the initial project scope might be include a number of options in a product or in a software or in a service. If we reduce the scope, we may consider to release it with limited option, and then later on we can, if we have the resources and time, we can either add it, or we can follow that approach of do it twice. That means an upgraded version will be released soon. Compromise quality. We cannot expect to have a premium quality job if we are really trading off with time. These are the factors that that can be considered, but again, how much you can compromise quality, again, that is a big question that I mean, not on the project manager. It should be approved by the overall management team. I mean, that should, the decision should come from the top management body. If the resources are not constrained, number one, things are very easy. We have as much as resource as possible. Just add where it needs, finish it as quickly as you can. If the resources are constrained, I mean, it can be tricky. There are many other approaches that people usually try, but there is no solid answer to that. How do you reduce the project duration if the resources are constrained? Okay, so reducing project duration. Now these are some factual information. The identifying direct cost to reduce the project time. There are two types of cost involved in the in any project. First one is any project related indirect cost. That includes what? Supervision, administration, consultant, and interest. These are the costs that if the project duration the indirect cost, this has a very linear increase with the overall project duration. The longer the project duration, the indirect cost increases at a linear rate, right? And another type of cost we can see is a direct cost that includes labor, materials, equipment, and any other subcontractor. Now, if we crash an activity, that means an activity is, say for example, scheduled for duration is 6 days, and if you want to do it in 4 days, crash it to 4 days, all right? That will be compensated by additional labor or material or equipment cost. That means if we crash it, any crashing activity will increase the direct cost related to that project. So if you shorten the project duration, direct cost will, but if you shorten the project duration, indirect cost will decrease. In the next graph, you can see that this is the indirect cost. We have the project duration in x-axis and cost in y-axis. So if a project has a duration of 6 days, this is the indirect cost. So again, I repeat, what are the indirect costs? These are consultant, okay, administration, interest, supervision, so the longer the project duration, the higher the cost will be. Okay, when it comes to direct cost, it is actually what? labor, materials, equipment are directly related to the project. So if you have a longer duration, that means you can possibly work with less number of people and equipment or materials. So that reduces the total cost. All right. This is the direct cost. So it reduces with the project duration. If you crash it, if you crash project duration, if you reduce project duration from 14 days to 6 days, the direct cost will increase from 20 to 40, almost double. Okay, so that means we need to look into the total cost that include the direct cost. So if you have a total cost graph from here, okay, so there is a minimum for every project, which is a combination of direct and indirect cost, and this is the total project cost. Okay, so this is the optimum point. This is the optimum point for any project. So if we have a project duration of 14 days starting from here, we can see that we can crash it. If we crash it, direct cost will increase, but indirect cost will decrease. But at some point we'll reach to the minimum, and then if we go further from here, we can see that again the total cost is increasing with every unit of reduction in the total project duration. So we need to find this optimum point. So this is the best point that we can operate a project. This is the lowest minimum duration that we can get to by trading off with the overall expenditure or money. Now, how do we do it now? Constructing a project cost duration graph. So that means we need to look into the project cost versus duration graph. We need to have the total number, direct and indirect cost, and then add it up, find the total project cost, and compare any additional cost alternatives if we have. Some of the considerations, how do we determine activities to shorten? I mean, if you look into the project network, there are usually, in big projects, it can be 50 to 100 activities within the project network. So what are the activities that we can shorten? Can we pick a random one, or is there any specific strategy that we must follow? If you have a questions, you can ask. Did someone raise hand? Okay, all right. So now out of the 50 or 100 or 200, I mean, depending on the project scale, there can be many activities within the project network. So which activities we can select to shorten? First of all, we call it shorten the activities with smallest increase in cost per unit time. I mean, the rule is we have to, based on the direct and indirect cost, we need to figure out what is the cost of reducing project duration per unit time. So if we have an activity for 10 days, if you're going to reduce it to 8 days or 9 days, for every decrease in the number of days, what is the increase in cost? With the, so this is the per day cost reducing that specific activity. To do that, there are some considerations that we usually take into account. The time cost relationship is linear. That means if you can identify that a specific activity can save us $20 per day, Okay, so that means this is a linear relationship. So for every day decrease in that activity will cost us additional $20. But in real life, it's not linear. It all depends on the type of activity, the material and labor you need. So the option is to make it really simplified. We consider that the time cost relationship is linear. Then the process is usually known as crashing any activity. If you ever heard that the crash the activity, that simply means that you need to reduce that overall duration of each activity. Okay, so some more considerations. Crash time represents a limit, the greatest time reduction possible under a realistic condition. That means what? There is a maximum limit that how much you can crash to. From 10 days, if you crash it, maximum, specific, maybe 7 days, maybe 6 days. So the maximum crashing time or the minimum possible realistic duration is you can't go below 6 days or 5 days. That should be determined. So the crash time represents a limit and the greatest time reduction possible for any realistic condition. You cannot possibly reduce the duration from 10 days to 1 day. So it has to be realistic that you can, with all the additional resources and people and money, you will still be needing 5 or 6 days. This is the minimum possible duration of any activity. The direct cost for completing an activity in its crash time is called crash cost. These are some facts. The slope represents the constant per unit time. Again, reiterate the fact that the cost time relationship is linear, and all accelerations must occur within normal and crash time. So we have a limit from normal duration and crash duration. In the activity graph, for any the duration of any activity, starting from 0 days to 10 days. Okay, so if we keep the normal days, this is the normal point, cost of 400, the activity cost. All right, if we reduce it to 5 days, this is the crash point. We can still do it in 5 days with an additional cost of 400. So the total activity cost will be $800. Now, can you go less than 5 days? Now, this is the minimum point. So that means what? Minimum realistic duration that an activity can be finished. So it all depends on a specific activity, but for every activity, there is a minimum possible realistic duration. So if it is for 5 days, we have the normal duration 10 days, very straight linear relationship. I mean, for each day, how much additional cost you need. We can calculate with the slope. If we calculate the slope from this graph with the duration and cost, we have the duration and cost, $80 per unit time. So for every single day of reduction in the total project cost, we have to budget an $80 extra. All right, so that gives us an indication of the total cost you need to crash any specific activity. Okay, this is done. This is for any single activity. This is activity cost. This is not the total project cost. So we need this number. We need this number for all the activities involved in the project chain, in the project network chain. So can it be cost-time relationship? Can be not linear, like for crashing 2 days, 4 days. I mean, with this approach, we are assuming that it is linear. So this is one of the consideration of this approach. But in real life, it's not linear. In real life, it's not linear. This is depending on specific type and set of activity, the project manager can decide which approach to follow. But a non-linear approach can also be followed that will cause the additional calculation, and it should be precise. Okay. But for these specific examples that we are discussing in the lecture, this is linear. But obviously, the non-linear option is also there. So we'll always consider linear. That's right. That's right. Okay. Okay. Now, a very simple table here. We can see that the activity ID and the slope or the minimum cost for reduction in the duration per unit cost and the maximum crash time. So each activity, what is the maximum crash time? You can see that it's not a big number, but 1, 2, 1, 2, 4. So this is the 4 days can be crashed. If it is 1 day, 1 day, 1 day, this is the maximum crash duration for each activity. All right. So if you look at the direct cost here, normal time 3 days. There is a 1 day crash time. That means it can be reduced by 1 day. So if you reduce to 2 days, from 3 to 2, the additional $20 should be added here. It goes like that. So from E4, from 11 to 7 days, 25 per unit, 100 should be added. So additional cost of 150 days. So very linear relationship, very straightforward. The trick is how do you determine the maximum crash time and the slope. These two are the tricky part. So you need to have a realistic consideration in the maximum crash. How do we calculate the maximum crash time? That's a very good question. So who delivers the activities? Now, it goes back to the question of who is actually responsible to finish the activities. These are the, everyone involved in any activity, they are the ones that decide that what is the minimum time they can finish it. Say, for example, if I give you an assignment to 3 members, you will get back to me, all right, we need at least 4 days to finish this assignment. If you can allow us 5 members, 2 additional members, we can possibly finish it in 3 days. So that feedback comes again from the project team. Everyone involved in that team, they decide that the minimum project duration. There are also some technical considerations, mostly in civil constructions or any mechanical related project. If it's a civil construction, say for example, there must be, if it's a concreting task, there must be some curing time once the concreting is done. So that is usually what you must allow the minimum number of days. Those are the technical considerations. Again, if it is if an activity is software based or anything with the web design, into that space, you can bring in additional resource and you can reduce the number of days. So that feedback again comes from so what is the minimum crash, what is the maximum crash time, or what are the minimum number of days that you can really finish each activity realistically. Okay. Then, okay, so next is this is an example here. So if we have a typical project with number of duration 25 days, all right, and the total direct cost of $450 here. Okay. Now, if you look at here, so these are this is the activity and this is duration. okay, and DOR for duration. All right. Now, the total time duration says 25. We have all the activities. All right. With any activity, if you can see that if you have the number X, this is the lowest possible time already, so we cannot crash that. Any activity with the number X, this is already the lowest minimum or the minimum possible duration for that specific activity. X cannot be crashed. And the rest of the activities here, we can see that 3, 6, 10, 11, 5, 8, these can be crashed. So from the previous table, we have the maximum crash time and the associated cost here. Okay, so A can be crashed by 1 day with an additional of $20. So if we crash activity A by 1 day, we now have the duration of A 2x. So x is 8. This is the lowest possible duration, so we cannot crash anymore. Activity A cannot be crashed anymore. The lowest possible duration is 2 days with the additional cost. Now we have the total project cost of 470. Activity is changed, is A will be now finishing within 2 days. And the total project duration now reduces down to 24 days. All right, next. Next is now which one we pick. It all, I mean, again, there is different strategies, such as, I mean, if we have a number of parallel activities, which one we crash? Obviously the one with the lowest cost. Okay, now in the next one we have what? We have B, C, and D. Okay, B, C, and D, all three, I mean, it can be crashed. We can see that B, C, and D, D can be crashed by 4 days, 1 day, and 2 days. And out of this, C is the lowest cost. So if you crash activity C, that is the smallest increase in the total project cost. All right. Okay, so if we go further here, we also need to look into the critical chain. I mean, all the activities if it's not on the critical chain, we don't. I mean, no point in crashing that activity. It can only helps us if the activity is on the critical chain. That can reduce the overall project duration. So from here we can see if we go BCD and then EF. So C, E, F cost pretty similar. So all three, we have exactly similar cost. D, a bit low cost. Okay. C, E, F will cost us exactly similar. So we have the maximum crash time 1, 1, 2. Alrighty. Okay. Now the next in the next move, I mean, what else? So if we from A, all right. Now if we crash F to initial normal duration was 5 days. Okay, if you reduce it to 4 days, no. So so out of this here, as I said from the beginning, like, so B, C, D, all three parallel, 40, 30, 25. This is the maximum crash time with the minimum cost. So if you reduce D by 1 day, okay, if you reduce D by 1 day, now we have the duration of D to 10 days here, all right? That will increase the total project cost to 495. Now we have a duration of 23 days. So once we reach to that point here, which one is a critical change? So we have 2, 6, 8, 8, 16, and then 6. How many days here? Can you hear me? Yes, that's good. All right. So we have 6, 8, 16, 6, 22. We now have here 12, 5, 17, 23. In this chain, we have 2, 10, 12, 17. So minimum duration is 23 days here. All right. So next, let's focus on DCE, all three. If you look at here, in terms of, if you look at the table, C, E, and F will cost exactly similar amount, right? Now, critical change, which one actually helps us in reducing the total project duration? So if we do, if we look into C, E, and F, so we have C, E, and F. Which one we go for? So if we reduce C, is still the project duration is again, there are 3 chains. So this one is 22, 23, and then 23. So if we reduce C, D is still 23 days. So it's not helping us in reducing the overall project duration. Okay. All right. Then if we reduce E, E is already on the shortest chain. So this is 22 days. If we crash E, it will reduce to 21 days. But again, these 2 chains will take 23 days. All right. So this will not help us in reducing the total project duration. So again, I repeat. So the next move is from C, E, F. If we have all 3 will cost exactly similar, but which one will be our pick? So let's now focus on F. So if we crash F from 5 to 4 days, so this will, now this chain 1 has 22 days, chain 2, again 22 days, and chain 3, 10, 4, again 22 days. Okay, so if we crash F, F is the activity that can really help us in the project duration to 23, from 23 to 22 days. All right, so let's crash F by 1 unit and reduce the project duration. Okay. Okay, now next is 22. Then if we want to reduce it further, F is already at maximum limit, so we cannot crash F anymore. A is also maximum limit, we cannot crash it anymore. Now that we have 22 days for each of the chain, we have what? We have 2, 6, 8, 15, and 6. Okay, so the next move is, if we want to reduce it, we need to change CDF, CDE, all 3 activities all at once. if we want a single unit of reduction in the total project duration, we must focus into CDE. CDE, all three should be reduced. Okay, so the unit cost will add up from this plus 25 plus 30. So that's a big jump. From 22, we have now 525. If we reduce it, if we want to reduce to 21 days, that is 610. It's a big jump. So now we have to decide that whether we really want that additional day of reduction to reduce the total. With that extra bit of money. All right. So the optimum duration is obviously 22 days. Now, if you plot the graph here, from project duration, direct cost, indirect cost, total cost. We have from 25 here, okay, 24 indirect reducing, this is direct. If you go down, this is the optimum point. Now, what is the indirect cost? We did not consider the indirect cost before, so we only consider direct cost. Usually it should be mentioned that for every day increase, there's an indirect cost of $50 or $100, whatever it is. So we always consider a linear increment in the indirect cost. That should be added and to the overall project, and we can see that anything below 22 days, the project cost increases again significantly. So starting to reduce, this is the minimum point, and then again start to increase again. So this is the optimum cost time point that is derived from the cost duration graph. Any questions? Any questions? Okay. So a very simple systematic approach of constructing the cost duration graph and finding the optimum point. There are some practical considerations. So use such as the crash time or the maximum limit you can crash. Linearity assumption. In most of the cases, it may not be linear. It may be the case that if any activity, if the duration of any activity is reduced by multiple, the direct cost may exponentially increase. It may not be linear. Choice of activities to crash revisited. Some activities are more riskier than others. We'll go through some more examples at the end of this lecture. So simply by the total amount of money to crash activity is not, it should not be purely focusing on the lowest amount of money. We also need to look into the risk factor for each of the activity. How much risk is involved if we really reduce the number of days. Time reduction, decision, and sensitivity. These are some other factors that we should consider, not only just money, but in terms of the risk factor, sensitivity. Can we take that risk of crashing an activity and shorten the duration? If anything goes wrong, the entire project can be affected. So the sensitivity issues, risk factor, these should also be considered in addition to that money factor. All right. What if cost, not time, is the issue? In that case, if we need to reduce the cost, that means I discussed that in the beginning of the lecture. Some possible ways could be reduce the scope. The initial scope can be very broad and very elaborate, very comprehensive. Some specific objectives can be avoided. Owner take more responsibility, outsourcing, or brainstorming some more cost-saving measure. So the key terms here: crashing, crash point, crash time, direct cost, indirect cost, and project cost duration graph. These are, now if you have any questions, please feel free to ask. Anything related to crash time, crash point, crashing, direct, indirect cost. If there's any confusion, raise your hand. The rest of the lecture is, there are some class exercises, and I put some solutions as well here. So exercise 1, do you want me to go through each and every exercises here? Hello? Shall I go through? Okay. Okay, all right. So we start from the very simple one here. We can see we have a table given and the project network given. So this is the project network, and this is the table with details of activity, ACT for activity, crash cost. This is the slope, linear slope that gives us the how much money we will be saving per day for reduction in the activity duration. Maximum crash time. So A can be maximum crashed by 1 day, 2 days, 0 days. What are the maximum limit that we can crash specific activity? These are the normal time and normal cost. All right. We also have the project network diagram given. Total initial project duration 12 days and total direct cost 1,000. So we have everything we need to start on this, start working on this, right? So we need to find the optimum point. We need to find the optimum cost for this project. So now, if you look here, which one will be the first activity that we can crash? A, that's right. Okay. First of all, as I said, so if we cannot just randomly pick. So from the beginning, let's pick A with 50. The cost is the lowest. Also, it will help us in reducing the total project duration, right? So now let's crash A to 2 days, and that will increase the project cost by $50. Okay. So if you reduce, the cheapest activity, so if you reduce A, if you crash A to 2 days, now the duration will be reduced down to 11 days with the total direct cost of 1,050. That's clear, right? Okay. All right, next. Then we have B, BD, and CE. Which one we go for? crash C. B is expensive, $100. C is $60. Okay. D is also $60. E 70. Okay. All right. So now we have a duration of now 11 days. This one is now changed to 2. We have 6. We have 6, 10, 11, 5, 8, 9. All right. How many days we have here in both the chains? Chain 1, we have what? 2, 5, 5, 8, 9. This is 9 days. This is 11 days. Okay. So that means we need to focus on this chain to reduce the project duration. So we will be focusing on C and E. We have 2 options, either C and E. So that will help us in reducing the project duration because this is the 11 days. All right. If we crash B, that will be reduced. So it's not helping us in reducing the overall project duration. Okay. All right. So this is 9 days. Now, so we have 2 options, either C or E. So C for 60, E for 70. So obviously our peak is C. That's right. So let's crash C. Okay, now C is crashed by 1 day. Now duration is now 10 days, 60 is added. This is the total project direct cost. Now the project duration is now 10 days, but chain A is 9 days. This is now 10 days. All right. So we still have option to crash 1 more day. C has a maximum crash limit of 2. So which one we crash again? Again. So let's crash C again to 2 days. All right. Now C again, crash it 2 days. Now we have a duration of 9 and additional 60 is added. Now both chain 1 and 2 now have got similar duration of 9 days. Okay, can you reduce any further? Can you reduce any further? Let's check. Okay, so if we want to reduce it further, now that we have both the chains with similar duration of 9 days, okay, so we cannot crash single activity. We need to crash 2 activities at the same time. So this one is C is 2 days. So C is already, this is 2x. That means we cannot crash C, right? We can crash B. Now that we have here, okay, so we can crash either B, D, or E. Okay. Yes, we can. We can still crash it. We can still crash it, but again, we have to figure out the total cost. So a single crashing a single activity will not reduce the project duration. So we need to crash B and E or D and E. We need to crash 2 activities to reduce to 8 days. So D is 60, E is 70. All right. And B is 100. So B is expensive. So we should not be looking at into B. We have the option of changing D and E together. So if we do D and E, this is an additional 130. All right. So if you reduce by 1 day, that's an additional 130 increase. So you can still reduce it to 8 days. So we need to reduce all the chains to same duration. Is this the main idea while we are solving numericals? Not to same duration. I mean, how we can reduce the project duration? If you can reach to same duration, that means both the chain now become critical. We have chain 1 and we have chain 2. Okay, initially chain 2 was critical. Chain 2 was 11 days, right? This is the longest duration and shortest possible time. Okay, now, so we only focused on the critical chain. So we crashed the activities on the critical chain. We crashed C by 2 days. This one was, and this one also helps us in reducing the overall project duration. Now that we crashed it by 2 days, now we have 9 and 9, both exactly similar. So chain 1, chain 2, both chain now became critical. Okay, so now if we only crash one of the activity from one chain, that will not help us in reducing the total project duration. So we must simultaneously crash 2 activities from both chain to reduce it by 1 day. So D and E is our option. There should be an added 130 additional cost per unit day reduction in the project duration. Okay, so there are some so if we haven't reduced B, still we go for D. The sequence doesn't seem to be. No, we don't follow the sequence. We look into the cost. We look into the total cost. So B is actually expensive. So B is, if we crash B, that will be actually $100 to crash. All right, we don't follow. We don't follow which one is the next activity that we can crash. No, it's not like that. All right. Do we know the total amount that is allocated for the project? I mean, so again, this is another critical question. If we are restricted by money, we should not even looking into reducing the project duration. All right, so another answer is, once you have this information, then you present it to the top management, like reducing by 1 day will cost this additional amount. Are you happy for us to proceed? So the top management have got some clear idea about the total cost related to the project reduction. All right. What is the requirement of end result? I mean, we can crash others as well. I'm not sure what does that mean. We can crash as long as an activity allows us to crash. So we need to look into the maximum crash time. So we cannot crash A because we already reached to the maximum crash time. We cannot crash C. We already used 2 units of crash time. We need to look into the maximum possible crash time. We are considering the crash cost to, right? So to determine which activity will be a preferred crash. That's right. Obviously, that's right. So now that we reach to 8 days here, 9 days, we have chain 1 and chain 2. This is 9 days and this is 9 days. Okay, so C is crashed to 2, A is crashed to 2. Okay, so we have, at this point, we have the option for B, D, and E. Which one we crash now? Okay, B is expensive, right? So we have the option of D and E. So we need to, but if we do D alone, if we reduce down to 8 days, this is 9 days, the project duration is still 9 days. Okay, So that means we must do D and E simultaneously. Both D and E should be crashed at the same time to reduce the project duration to 8 days. Does that answer your question, Alice? We are trying to find the optimum cost time point. That's right. Do we know the total amount that is allocated? This one is, this approach is considering the fact that we have the money, we just need to reduce the project duration. So it will also help us in identifying the extra money needed per day for per day reduction in the cost. So that should, again, the top management is in a position to decide whether, that additional cost is justified. We can reduce time as much as the crash limit. We can reduce time as much as the crash limit for each specific activity. Okay. The concept is by minimizing all the given activities possible with the cheapest cost. Cheapest cost is the first approach. Okay. If we have, if it is a chain, or if we have only one critical chain, that means out of all the activities within the critical chain, the lowest possible or the cheapest cost is the option. If we have multiple critical chains, such as these 9 and 9, so if you have multiple critical chains, that means we need to reduce activity from each chain to reduce the total duration. So again, cheapest is the option. So from chain 1, we can see that B is expensive. Obviously, we should not crash B as compared to, so between B and D, D is a clear choice. All right. But at the end, what about we can keep crashing the time until maximum allowed. That's right. We can keep crashing it until maximum, but at the end, when you plot the graph to indirect cost, direct cost, and total cost, then we'll be able to tell exactly this is the optimum point, and this is the lowest point. You can keep crashing it, you can reach up to the lowest point, and you can also identify the optimum point. What is this all about? So this is all about identifying the extra cost you need to reduce per day reduction in the project duration. All right. So the more information you have, the better it is for the management, for the top management to decide. All the chains be critical at the end. Is that necessary? Yeah, so that's why. So that's why in the previous slide we discussed about it induces some additional risk. So that means we have more critical chains. So there is a risk factor obviously involved. You can unmute yourself and you can speak if you like. So we can pursue time and cost. So if time is the factor, cost we must provide the additional cost. So there is a time cost trade-off issue always. The goal is to minimize the project duration, finding the critical path with the cheapest cost possible on all activities. The goal is to minimize project duration with cost involved for each unit of reduction in the total duration, finding the lowest point, finding the lowest possible duration, and also the optimum point. Optimum point is the lowest total cost Okay, and the lowest duration will not be the lowest cost. Lowest duration of the project will be at a higher cost than the optimum point. On that increase the cost, that will increase the, I mean, not sure what is your question, but obviously that will increase. From optimum point, the cost will again increase. That's right. So Rayman is asking, suppose we can reduce the chain 1 duration to 7 days and chain 2 duration to 8 days. 8 days. Then we go for that option. What is your question? Not sure. Can you repeat, or you can unmute and you can speak on your microphone. Mark, finding the critical path is the top priority. Now the cost is that's correct. That's correct. But you also need to look into all the crash activities should be on the critical path. If there is only one critical path, we can focus on one. We can focus on the cheapest activities within that critical path. If we have multiple critical paths, then we need to look into, in the class example, remember that we crashed all 3 activities, D, C, E at the same time to reduce by 1 day. And that will increase the total project cost. So if you start from C, then one path will be CEF, and other CABDF. What is your question? I mean, it's I didn't get it. We can't start from C. So A is the starting point. A is the starting point. So we check the duration starting from A. We have chain 1 and chain 2, both are starting from A. A is the burst activity. A is bursting into B and C. From C, we cannot go to A. No. All right. There are 2 chains, both are originating from A. Okay. We started from A because it was the lowest cost. Also, A it was the lowest cost. Also, you need to check whether crashing an activity is actually helping us in reducing the overall project duration. So A is a starting point. So if you crash A, that will reduce the duration in both chain 1 and chain 2. All right. Okay, we have some more examples, more class exercises here. So now if we crash D and E simultaneously, that will be an additional higher amount of cost. So we have D and E both crashed, duration 8 days, an additional cost. Okay, so that means lowest duration 8 days, but that will increase the total cost. No, we cannot crash A one more time. The crash limit, we have to follow the maximum crash limit. This is the maximum crash limit. We can maximum crash it by 1 day. This one by 1 day, this one by 2, 2, 1, 0. Okay. So let's move. Okay, another example here. So if we crash C and D, if you crash C and D, in the previous example, so if you crash C and D, C or D.
Another bank.
Sorry.
अहिले एकछिन कल गर्छु या म यहाँ अनलाइन क्लासमा छु के त्यही भएर अहिले गर्छु
Please mute yourself. Okay. As you can crash 2 times, so I'm asking how it will work. So you mean from the beginning, if we crash exactly C and D, chain 1 was already lowest day. So chain was already on 9 days. So there is no point in crashing C and D simultaneously. We can only crash C and reduce the number of days. We cannot pick random activities to crash. There are 2 checklists that once we decide to crash, first one is which one will cost us lower amount or which one is cheaper option. Second is whether that will reduce the project duration. So we need to look into this is the number, not just random pick and if we crash B and D from the beginning, that will not help us in reducing the project duration. So we need to look into the total duration of the chain. All right, let's move on to next example and be more clear. So here, all right, exactly similar problem. All right, now we have the activities given. Okay, slope given, per unit cost in dollars. Okay, maximum crash time given. So A cannot be crashed, not by single day. F cannot be crashed. We can crash B, C, D, E. All right, normal time and normal cost is given. Okay, now here, which one we start from? We have a project duration of 13 days. Okay, now you tell me, can we crash A? Yes or no? No. So that's clear. All right, that's clear. So we cannot crash A. There is no crash limit for A. It's already 2x. That's fine. We cannot crash A. Now the next option we have is B, C, D, E. We have a number of options here. So which one helps us in reducing the project duration or cost? B. Okay, so now let's check. Now we have what? We have chain 1. Initially, we have chain 1. This is chain 2. Okay, so how many days we have? 3, 6, 9, 10. 10 days. Okay, 3, 4, 7, 10, 11. Okay, so if we add including A, all right. So this is now 12. This is 13. Okay, now we have two chains. One is A, B, C, F. Another one is A, B, D, E, F. A duration is 12 days. A, B, D, E, F duration is 13 days. Okay, we cannot crash A. We can crash B, C, D, E. We can crash B, C, D, E. Okay, which one we pick from B, C, D, E? D, 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 D. Okay, now let's check. All right, so okay, so now we will pick obviously the cheaper option. Also, in addition, that will help us in reducing project duration. So here we can see chain 2 is now critical with longest 13 days. Okay, chain 2 is the longest duration with 13 days. This one is 12 days. So if we reduce any of the activity from B, D, E, that will help us in reducing the project duration. Okay. So from here, D is the cheapest option. Now let's crash D. That's right. So let's crash D. Project duration 12 days. This is the total project cost. Now, is that clear? That should be crystal clear, right? So from the beginning, you can see that we have two chains, and we have in chain 2 we have 3 options: B, D, E. Which one we pick from? B 100, C, D 40, and E for 50. And we can crash any of these 3 activity by 1 day to reduce the project duration by 1 day. And D would be the best pick because of the lowest cost. All right. Once we now that we crashed D by 1 day, which one will be the next pick? Now this is now 3 days. Now chain 2, chain 1, chain 2, both now 12 days. B would be next, 100. We also have an option of C and E. C and E. Okay, so we have both options. We can either crash C and E, both, so C for 50, E for 50, and both are limited by 2 and 1. That will be in total 100, or B for 100. Okay, both options are exactly similar. All right, so now If we, from here, next is, we have either B or C and E, both options. So if we crash B, that will be 11 days, additional 100. Again, from here, if we want to reduce by 1 day more, both C and F should be crashed. Both C and E should be crashed. All right, additional 100. So that's how we proceed from by crashing each activity and by checking the numbers. The lowest possible duration is 10 days with the cost of this. If we plot a cost duration graph, we'll be able to find the optimum point. Next one here, exactly similar way. Now we have activities given. And maximum crash time given and cost given. Okay. Which one will be the first pick? C, D, expensive, E, F. F is the cheapest, F and G, these are the cheapest option. But again, let's look into the total chain. B, 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 okay. So let's check. So we have 2, 4, 6, 11, 14, 19, 20. Okay. Again, 2, 4, 6, 11, 15, 11, 14, 18, 19. Which one is critical path? This one. All right. So let's focus on the critical path. Starting from A, B, C, E, F, H. This one is the longest duration. Okay. We cannot crash A. It cannot be crashed. B is an option with 50. We have C, 200. Then E, 100. F, 40. Okay, so did you get the point of actually what is more effective in reducing the project duration with the minimum cost? So F is the lowest cost, and it is on the critical chain with the minimum cost of 40. Okay, so why not F? Okay, so if we crash F to 4, that will be now 19 days. Okay, so the direct cost will be added by 40, and the total cost will increase. So reducing F by 1 unit to 4 days, this one here, 4 days, that will give us the shortest duration to 19 days. Okay. Now that we have a duration of 19, that 40 should be added, and the total project cost here. Now remember, the question says there is $100 per unit of reduced in the indirect cost. So if for every day of reduction in the indirect cost, we can take off $100. So we add 40 and then we take out 100. We add 40 here, 40 is added. Then again, this is minus 100. So this is the total project cost. Whether B is next, that should be checked properly. That should be checked from, as I checked from the beginning, from the total duration of specific chain, amount it cost. All right, how do we trade off? Now, next, in the next point is, now that we have 19 days for both, all right, obviously B is the choice from here. Okay, so now let's crash again B by 1 day, reducing B 1 day, 50, that is 50 added, 100 reduced. All right, total cost is reducing again with the duration. Next, now we have 18 days. So can we crash B any further? No, because we reached the maximum limit of 1 day. All right, so we crashed F and B. Now the duration is 18. Okay, now the duration is 18 in both the chain. We have option for C, D, E. Okay, C 200, D 200, E 100. Which one you pick? Give me your clever answer. Which one you pick? Okay, so E is common to both the chain, right? If we crash C, we also need to crash D. If we crash C, that means chain 1 will be 17, but chain 2 will still be 18. So we need to find, obviously, E is the lowest. Also, E is common to both chain. That's right. So now let's crash E and reduce it to 17 days at 100 minus 100. Project cost remains still the same. Okay. All right. Then yeah, E is done. E is done. Okay. Now next is so once we crash E, now we have 17 and 17. Okay. So we only have two options, C and D. And for each of it, we have to do both simultaneously because both are now critical chains. Both are by the duration is now 17 days. So we must crash both C and D at the same time. If we do it, that will be additional 400. If we crash C and D each by 1 unit, that will be 16 days, additional 400, but a reduction of 100. Project cost will increase. Can you do C and G? We can crash C and G. We can also crash C and G. That's right. So from this chain, we have either D or G both. We have an option of G. That's right. That's right. Yeah, so this is where we now we reach to the optimum point. From that point, the total cost will again be increasing. Once we reach to the optimum point, if we reduce it further, total cost will again be increasing. So that's why we need to find the lowest possible point and the optimum point. That's right. Yes. We can go, but the total cost will be higher. Okay. So here, either C and D, or we can also try for C and G. Both are okay, but in any case, we will see that from optimum point. This is which one was our optimum point? 17 days, right? This is the optimum point. So from optimum point, if we start plotting this is indirect cost, and then we have the direct cost and the total cost. This is the optimum point for 17 days. Anything lower than 17 will be the project cost will increase. So if you have this information starting from the normal duration and each day, how much the total cost will change. All right, from this specific example, you can see that we can reduce it by at least by 3 days. Is still having the same total cost. It's a flat curve. Okay, so if we have all this information, then it's up to the top management to decide how many days they want to crash this additional money, whether it is justified. All other factor they can consider if they have the detailed information about the total money involved in crashing the activities. All right, next one. Shall I go through it? Okay. So this example here, so we can see that, let's read the problem statement. So we have the indirect cost given, so that's $50 per week. What is the optimum cost schedule for the project? What is the total cost? Okay, we have the normal duration 7 days and total direct cost 2,000. A cannot be crashed, so let's check the number of days for each chain. We have 3, 4, 7, 10, 12, 14, right? Okay. How many chains are here with the total? What is the total duration of each chain? So we have chain 1, 14. Then we have 3, 4, 7, 11, 15, 17. Okay. Then we have 3, 6, 8, 12, 14. All right. So this is longest duration, 17 days. So which one is our critical path? So let's 3 chain 2, 7 okay. Yes, so AC, AC, yes, we have 4 chains, but which one is the longest one? A, C, D, H, I. So in C, D, 3, 6, 10, 14, 16. So A, C, D, H, I, that's 16. So the critical one is A, D, A, B, D, H, I, 17. Yes, that's right. So we can focus on A, H, I to reduce the total project duration. The very first step. So A cannot be crashed. A is the maximum. A is we don't have a crash limit for A. Now we have options for B, D, H. Which one will be our pick? H for 60, B for 100, D for 40. That's right. D. That's right. Okay. So now the first activity that you can crash D by 1 day. This will be now 3 days. Now the duration will be 16. All right. Crash D. Additional 40. Indirect cost will reduce by 50. This is the total cost. Alrighty. Next. Which one is next? Now we have among the 4 chains, we have 2 14 days and 2 16 days. Okay, so D is already done. We don't have the option anymore. Now we have options for B is obviously expensive. Then we have H for 60. So we need to look into any of the activity from the longest chain. All right. So we have 14, 14. That's not. So I mean, if you look into it's still, if you look into A, B, D, H, I, that's 16, or A, C, D. Any questions? So H is common in both chains. So yes. So now let's so if we crash H by 1 unit, add the additional 60, we have now the total cost. So that's how you proceed one by one and check. The first thing is check which one is the longest chain, and out of the longest chain, check the activities, which one has got the lowest cost. All right. So H is crashed. All right. Now next, once we crash H, we now have a duration of 14 days. So we have a limit of maximum 2 days. All right. So once we crash H, that's 15. Again, we have another option to crash H again to 14 days. Okay. Then if we have if we reach to 14 days, that means we use both units of H. Now we have the total duration is reduced now to 14 days. Okay, this one is now 2. All right. Whether we can crash it any further. Now let's check if we reduce B by 1 day, how much will be the total cost. All right, from that point, whatever remaining balance of crash time we have, let's apply one by one by applying the principle of from the longest chain and the lowest cost reduced by 1 day, get the total figure, and then plot the graph, final graph. So we can see if we have an option for B, so from B, from 14 days, the total cost will start to increase. 14, 13, from here, we can see that the total cost will increase. So you can have a very clear optimum point, or you can see that starting from here, this is a very slow increase to 13, and then you may not see that sharp increase with the number of days. So in some cases, finding the optimum point may be a bit difficult, but it is the point from where the total cost will again start to increase. That will be the optimum point. Okay, any questions? Any questions out of all these exercises here? Please unmute yourself, because I can't possibly read all the chat from the window and answer your questions. So you can unmute and you can talk. No questions. Okay, I'm happy to repeat again. If there is any confusion, I'm happy to repeat again. Now, in the next part of the lecture is managing project team. This is very narrative, so please have a look, read the statements in each of the slides. There's not much to explain here except how we can work in a team. I don't see anything that that I need to explain here, but if need be, I can. We only have less than around 5-6 minutes of today's lecture. Now let's open for any question and answer that you may have. Any question and answer you may have. So we can continue. If you like me to, I can continue from this point next week. But these are mostly narrative slides here. Okay. Any questions? In the last example, 14 days was the optimum point. Case study 1, we'll try to release the marks as soon as possible. We don't have answer written in slides for question 1 to. All right, I will update the slides. Check the updated slide.
Excuse me, sir.
Yes.
So I want to ask you regarding the project groups. So since from next week or this week we have to start regarding the project, or when will you be giving us?
I will announce through iLearn once the project questions are released. I was hoping to release it by week 7. So this is the today is the first day of week 7. So up until Friday, we'll expect to see an announcement through iLearn about the detail of the group project. Again, I've been receiving emails from some of you that you want to have a group members 6 or 7. This is really not encouraged. Maximum 3 to 4. Maximum 4. You should really be limiting it to 4, because the size of the project will not. There won't be enough contribution for each of the members. If 7 members in each group, I mean, it's not. I mean, there are not enough contents for each of the member to contribute if it's a large group. I suggest keep it to 3, maximum 4.
Okay.
Okay.
Yep. Thank you, sir.
When will case study 2 be uploaded? Okay, so you want the case study 2? All right, I'll do it as soon as possible. So how was case study 1? I will provide a link to submit your group member's name for those. If you have a preferred group, that's fine. If not, if I see anyone without a group, I will allocate you randomly. But there will be a link to submit your group member's name. All right.